So here we go, jumping back in. The first step is always factor. So if you see all these x's, I can take out an x. So if I start with that, I'm left with x squared plus 6x plus 9. And if I factor that, y'all can whisper, it's not going to pick you up. So sum to 6, product of 9. 3 and 3 means when you get the same number there, it's a PST, or perfect square trinomial. So that can factor even more. So now my numerator is x times x plus 3 squared. And this is not a difference of squares. X squared plus 1, sum of squares, yes, but that can't factor. So my numerator factors, my denominator does not factor, and there's nothing that cancels out. So that's what I'm looking at now. So jumping in with RATEY, R stands for roots. When I set my numerator equal to 0, I get x is 0. And I get that x is 3, negative 3. But there's a catch to this one. So x equals 0 is going to look linear at my x-intercept. But this x-intercept, this goes back to polynomials and the multiplicity of 2. Can't talk. It's going to bounce and it's going to look quadratic. Which means on my graph where x is negative 3, it's going to bounce. Just like I did with polynomials, it doesn't matter that it's a rational function now. That multiplicity, that bouncing rule still applies. So A, asymptotes, set my denominator equal to 0. So if I have x squared plus 1 and I set that equal to 0, x squared could equal negative 1, square root it, and you get imaginary, which means that there is no vertical asymptote. Because there's nothing that I can plug into this denominator to give me 0. If I plug in negative 1 squared becomes positive 1. 1 plus 1 is 2. Hey, I'm filming, just heads up. Okay, T, togetherness. Togetherness means do you have any perfect square trinomials or terms squared in the denominator? And I don't, because I have x squared plus 1. That's not x plus 1 squared. That would work. But what I currently have is x squared plus 1, so no togetherness. And E, end behavior, heavy, looking at those horizontal asymptotes. This one's top heavy, x cubed over x squared. So, bottom, this one has no horizontal asymptotes. So my domain and my range for this graph would be negative infinity to positive infinity because there's no asymptotes at all. There's no restrictions on this. And then y-intercept, plug in 0 for x. So 0 squared plus 6 times 0 plus 9 times 0 all over 0 squared plus 1. Well, my numerator is 0. 0 over anything is 0. So now to go to my graph and to graph that. Remember, I have no restrictions, so no test points, no quadrant checking. I know I have a point at 0, 0 because it's my y-intercept. I know I have a point where x is negative 3. And I know that my graph has to bounce at that point. Remember, there's no restrictions. So this goes back to polynomials. And the whole even, odds, up, down, negative, positive, all of that. So x cubed, I'm looking at my numerator now to guide me. So x cubed means that it's odd. My leading coefficient is positive. So remember that odd and positive started down and ended up. So I need to start down and end up, and I need to bounce at this point right here. So that's what I'm going to do. Start down, bounce, pass through, and end up. And that's it. So this one looks more like a polynomial than a rational function because there were no asymptotes. So there was no restrictions on that graph.